Normally we think of a hole as a hole in the floor, and you fall through, come out the other side. Except it's a three-dimensional hole. You can fall in any direction. That edge, beyond which there's no return, we call the event horizon. It's a horizon. The universe has a horizon too. It is a distance beyond which no information can reach us, because the universe isn't old enough for light from anything beyond that horizon to have gotten here yet.
So, why does the universe enforce boundaries you can't cross, even though there's no wall there? We're used to edges being made of stuff, fences, cliffs, locked doors, but the most consequential boundaries in the cosmos aren't material. They're drawn by the speed of light and by time itself. Light doesn't just move fast, it sets the fastest possible way anything can influence anything else. Pair that with a universe that has a finite age, and you've created a limit. A sphere around us containing everything that has had enough time to send a signal our way. But that's only the beginning. Gravity curves space-time. Motion reshapes what you can see or touch. Horizons are not the same for everyone, everywhere, at every time. They depend on circumstances, which raises the stakes. Does who you are, how fast you accelerate, how deep you are in a gravitational field, or which epoch you live in, change what your boundary is? How does gravity or acceleration decide your horizon? Relativity answers the earlier question. A horizon exists because causal influence travels along light's pathways, and space-time geometry decides which pathways connect to you. In curved space-time, those paths can be cut off. Collapse enough mass and you form a black hole. Its event horizon is a surface from which light can't escape to you, not because light slows down, but because space-time carries all future paths inward. Sustain constant proper acceleration, and you create your own Rindler horizon. Regions behind you cannot send signals that will ever reach you while the acceleration continues, a purely kinematic, observer-dependent boundary. And in a universe whose expansion accelerates, there exists a cosmic event horizon. Beyond a certain distance, light emitted today will never reach us. No walls, just the rules of causality at work. But horizons aren't just static markers, they can shift. Do these boundaries evolve? Can the dark sky brighten with new arrivals tomorrow? Or will some galaxies we see today drift beyond reach and fade forever? Can horizons shift over time, letting the unreachable become reachable, or taking things away forever? Yes to both, depending on which horizon you mean. First, answering the prior question, your motion and your gravitational environment do change what counts as inside. An astronaut under constant thrust has a personal horizon. A stationary observer far from a black hole and an astronaut falling in disagree about what's accessible, because their light cones tilt differently. Now, about evolution, our particle horizon, the farthest place we can see today, grows as more ancient light finally arrives. That's why the observable universe is larger than the naive age-time speed of light. Expansion stretches distances while light is en route, but there's also a cosmic event horizon defined by the universe's accelerated expansion. Beyond that boundary, even signals sent now will never reach us in the future. Many galaxies we currently observe are already beyond that event horizon. Their next chapters will never be broadcast to us, and black hole horizons grow when they eat and shrink very slowly by Hawking radiation. If reality can be both revealed and concealed by shifting horizons, what does that imply about truth in science and our place within an incomplete view? What does it mean for science that horizons can both open and close? It means we anchor truth to what is causally testable while using the universe's own imprints to infer what lies beyond. Some darkness will brighten. As time passes, light from regions just inside our future reach will arrive, adding to our cosmic map. But accelerated expansion imposes a final ledger. There's a finite set of future signals we can ever receive. The night sky will, in the far future, grow lonelier as distant galaxies redshift out of detectability. That's not a failure of science. It is a feature of the laws that make science possible. Horizons are bookkeeping for cause and effect. They tell us where experiments can matter and where only inference is allowed. We can still probe beyond through relics, cosmic microwave background patterns, light element abundances, and searches for primordial gravitational waves, fossil records imprinted within our horizon by physics from epochs earlier than any light can show us, such as quantum fluctuations stretched across cosmic scales by an early inflationary expansion. And we refined confidence by checking that the same physical laws describe everything we can touch. So, the perspective shift is this. Horizons are not edges of the universe. They're edges of influence. They move with time, with motion, with gravity, and they teach humility without paralyzing curiosity. We don't need the whole book to do science. We need the pages we can read and the discipline to infer the binding. That is enough to understand where we are, what we can know, and why some mysteries are not barriers but boundaries to be mapped with precision. Like if this was interesting, and hit the subscribe for more.